In this video, I am going to demonstrate the procedure of titration to find the unknown concentration of hydrochloric acid against a primary standard solution of sodium carbonate, which is 0.05 moles per litre. This experiment has been separated into two parts. First, the making of the primary standard solution, and then the titration to find the unknown concentration of hydrochloric acid. Prior to the experiment, obtain a certain amount of aqueous sodium carbonate solution that needs to be heated to ensure the evaporation of water to leave behind sodium carbonate solid. This can be prepared through an evaporating dish over a Bunsen burner or in a drying oven. Agitate the solid periodically with a clean glass rod. Once the water has completely evaporated, transfer it to a desiccator and label it as sodium carbonate. Safety is an important part of this process as there are many risks involved. It is mandatory that eye protection is worn and tongs are used as the apparatus and the solid will both be hot. It is also important to note that sodium carbonate forms a caustic alkaline solution with water. So, if it does spill on skin, it needs to be immediately washed off with plenty of soap and water. Firstly, weigh out 1.33 grams of sodium carbonate solid to make approximately 0.05 moles per litre in concentration. Use an electronic balance and record to 3 decimal places. Then, rinse a stirring rod with deionized water to ensure that no other contaminants will affect the accuracy of the concentration of the solution. Add some deionized water into the beaker with the sodium carbonate and stir vigorously with the pre-rinse stirring rod until the entire mass of sodium carbonate is dissolved. When removing the stirring rod, ensure that it is rinsed to inhibit the loss of any particles of sodium carbonate. Take a 250 milliliter volumetric flask and rinse completely with deionized water to avoid other contaminants to affect the concentration of the primary standard solution. Similarly, rinse the funnel. Then place the funnel on the volumetric flask to transfer the sodium carbonate solution from the beaker. Once the transfer is complete, rinse out the beaker and funnel with deionized water to ensure that no sodium carbonate solution is left behind. This is done to ensure an accurate concentration of the primary standard solution. After this, start adding deionized water and periodically invert the flask to ensure that it is completely mixed. Fill the volumetric flask until the calibration point with deionized water. When reaching closer to the top graduation mark, add dropwise to ensure it does not overfill. The bottom of the meniscus should lie exactly on the calibration point. Make sure not to go over the graduation mark, otherwise this entire process needs to be repeated. Cap the volumetric flask and invert several times to mix. Make sure this is done 15 to 20 times to ensure that the solution is completely mixed. The standard solution is now ready to use. After this, start the second process, which is titration. To ensure this process, set up the apparatus for the equipment. Set up a retort stand with an attached burette clamp and ensure that the height it is being placed at is accurate for swirling the conical flask without losing any solution. Rinse a 50 ml burette with deionized water, ensuring that the tap is closed, hence making sure that there are no other contaminants present within the burette and letting it through the tip as well. Similarly, rinse the burette with standard solution, letting some of the solution flow through the tip as well to maintain the same concentration throughout the experiment. Take the burette and fill with standard solution until the value 0 and ensure that the bottom of the meniscus sits on the calibration point. Use the previously rinsed funnel to aid the transfer. Ensure to remove the funnel to ensure accurate measurements and clamp to the retort stand with the burette clamp. Rinse a 100 ml beaker with hydrochloric acid. Use the same beaker to obtain some hydrochloric acid of unknown concentration. Rinse a 200 ml conical flask with deionized water and place under the clamped burette. Then rinse a 25 ml pipette with deionized water from a previously rinsed beaker. Then rinse the pipette with hydrochloric acid obtained to ensure an accurate concentration. Using the pipette, measure 25 ml of hydrochloric acid, which is now your aliquot. Ensure that the bottom of the meniscus lies on the calibration point. Rest the tip of the pipette against the inside of the wall of the conical flask for a few seconds to ensure the liquid fully transfers. Place a white paper at the bottom of the conical flask to ensure that the color change is visible. For the color change, add 2 to 3 drops of phenolphthalein indicator. Add the solution from the burette to the conical flask slowly, swirling the flask periodically. Determine the volume of primary standard solution needed to reach the end point with 25 ml of the unknown concentration as the color of the solution goes from colorless to a pale pink, and record the value when this occurs. The first trial is now complete, but the titration process needs to be repeated at least 3 more times to ensure accurate and reliable results. Calculate the average volume of the primary standard solution used in the 4 trials and use it to calculate the concentration of hydrochloric acid.